Okay, so we've looked at the concrete syntax for functions in Lattice, and we've also looked at the abstract syntax. And hopefully you are able to sort of see how we would transfer from the concrete to the abstract, right? We have function def, where this string corresponds to the parameter, and then this is the body of the function. And then function call, where this is going to be the identifier or the function itself, and this is going to be the value that we're passing to that function. And in order to figure out how are we actually going to do this, right? How do we make a definition and then do a bunch of extra work, and then maybe come back and call that function? What we're going to do, what we've done is we've added a new type of value to our system, right? So before we could have numbers, booleans, or errors, and now we have closures which represent functions, right? They keep track of everything that we need in order to run a function. And a typical closure is going to look like this: closure with a expression or with a string, which is going to be the parameter, and then an expression, which is going to be the body of the function, and then an environment, which is the environment at the time we define the function. All right, the idea here was that we want to have static scoping in our language, so we want to make sure that whatever function or whatever variables were defined but right before we made our function, right, we want to make sure that we capture that. And we do that just by taking a full copy of the environment and popping it into this closure. So then this closure will end up in our environment, typically bound to another variable name, right? Or we might construct it on the fly depending on the situation, like when we have nested function definitions, in the currying syntax, the currying form. So now let's look at the semantics, right? This is when we want to actually say, if I have my eval function and I look at a big Lattice program and I come across a fundef, what do I do? Right? So we're going to start by, we're going to do an eval of what happens when I see fundef on some string s and an expression e under some environment. What do I want to return there? Right? Well, I just said what we really want to do is we want to return this closure. So is there anything that we need to evaluate first? Well, not really, right? This is just a string, and this is the body of the expression, but we aren't going to really be able to do anything with that expression until we are able to bind a value to this s, which we do through funcall, right? At the moment of definition, there's really nothing for us to do. So all we really want to do here is return the closure of, well, let's see, what do we need in closure? The string, so that's going to be s, the parameter name, the expression, so that's going to be e, and then the local environment at the time that we made this definition. And that's it, right? So really, there's three component parts to this fundef, right? There's the two parts with fundef and then the local environment, and the closure is just capturing that environment. That's sort of the key point here. So that's all we do when we see a fundef. We just pass back a closure. The more complicated bit is going to be when we call the function. So let's see what that looks like. All right, so we're going to eval funcall on some expression. I'm going to call that f, and some other expression, which is going to be our parameter, so I'm going to call that x. So let's call it e1 and e2. Kind of want to keep it a little vague, right? Because even though we sort of know that that should be x, the parameter, or the name of the function, and then the parameter, we don't actually know quite what they are. They're just expressions. We'll have to deal with some error cases if it fails, right? So this needs to be evaluated with a local environment. And what do we need in order to be able to calculate this, right? Well, funcall, we pass it a name, so we need to look that up, right? So the first thing we do is we look up E1 in our environment. And E1, right, that's the name, so it should be an ident of something, and it should be bound to a value, right? That's what everything that's in the environment is. It's some name bound to a value, and that value should be a closure. So this should be, let's call it V1, and V1 should look like closure of, well, we have a string, an environment, or a body of the function, and the environment. Let's call this F environment, because it's the environment of this function locally, as opposed to our normal environment that's floating around when we're evaluating this, right? This is what's been captured at the moment of when we define the closure the first time. So if we know this, what are we going to do? I want to evaluate E, right? I want to go through the body of my function, but I want to make sure that I replace S with whatever E2 evaluates to. So I need to evaluate E2 first. So let's eval E2 under this environment, right? When I'm thinking about, I want to call foo on 10 plus 20, right? I want to make sure to fully evaluate this down to a number or some sort of value that I'm going to then pass through, right? And I do that under my current environment. So we're going to do this, and this should turn into some value that's not error, right? So as long as this is V2, and as long as V2 is not an error, then we should be okay. So then what is our final call going to be? Well, right, what did I say? I want to evaluate E, right, the body of my function. And I want to do that, but with S bound to V2, right? So I want to take whatever my parameter value was and bind it to whatever I'm passing into my function. So I'm going to do an extends S V2 env. And actually we want to extend the functions environment. Right, because that's the whole point of capturing this f env in our closure, was that we want to make sure that whatever variables that we're looking at were captured at the time of definition. And so when we evaluate the body of our function, we want to make sure that we're doing it with the local environment, or with the captured environment, extended by our parameter choice. So yeah, that looks like quite a bit of stuff, right? But I didn't really say too much, right? All I'm saying is that look up foo. Foo is a function. So we have this closure that essentially represents, right, function of x, and then we do something. Right, this is E, this is S. And so, yeah, what do? We do fun call of E1, E2 under our current environment. So what do? We look up E1, try to find that name in our environment. That should give us the closure that represents this whole thing, right? That's this closure right here. So S is the parameter, E is my body of my function, and this is our environment that I captured with the closure when we first defined this function. And then we eval E2, right? So we figure out what are we passing to our function, and that should be something besides an error, because we should be willing to pass in booleans or numbers or even other functions. That leaves us a lot of room to make interesting computations, right? So yeah, as long as this does not turn into an error, then I want to evaluate the body of my function, right, under the captured environment extended by the parameter definition, right? So x should be bound to whatever E2 evaluated to, which is V2. So hopefully that makes sense to you. right, we didn't really go through much. It's just mostly a mathematical definition here. It's exactly what you'd expect a function definition to do. The trickiest thing is this idea of a closure, right? That a closure captures all of this information. We want to make sure that we use it all correctly. And then there's basically one other possible option, right? So we could either, we have the error situations to deal with, right? So if we look up E1 in our environment, we might not get a closure, right? If V1 is not a closure, well, then you're trying to do something like let x equal 10 in x of 20, let's say, right? We're trying to call x as a function, but x is not defined as a function. So we should have an error case when this happens, right? So we should have an eval of funcall of E1 and E2 under an environment. Well, if lookup E1 in the environment is an error, right, then we just want to return an error, right? So this is funcall error 1, right? What's the other possibility that we could have? So actually, I should just say if this is not a closure, right? Not just that it's an error, but it could also maybe return a number or a Boolean. But we want to make sure it returns a closure. So if it doesn't return a closure, we should throw an error. When else should we throw an error? Well, we could do this lookup. We still get a closure. And now we evaluate E2 under our environment, and we get an error, right? That's the only other real case here. That's the only other thing that we said would be bad if that happened. So we have our lookup, right? Is going to be this V1, which is the closure, and then we're going to have this evaluate E2 under our environment. And if this is equal to an error, then I want to return an error. So this is my funcall error2 rule. And this would be, our funcall error, or funcall OK rule. So that's the abstract syntax. If you look at the Jupyter that's the abstract semantics of this, so the big step semantics of this. If you look at the Jupyter notebook, we actually have all of it written out in Scala and implemented. So you can play around with it and really see what's going on. Also, you can do this in the Lettuce playground, where you can actually, implement some concrete Lettuce statements with function definitions and see how it all works out.